I've just been vibing the last, well, I've been on vacation, so and haven't, by my standards, not as prolific as normal. But where's Corporate Cloud? Here we go. Here we are. This is the first one of 2026. Yeah, I've been on a sort of, I don't know, I don't know what you want to call it, like a focus on very tight learning loops, a lot of memory, a lot of the vector sort of attention systems, and creating things that really will facilitate that. And Stu, you said you've been playing with the system a little bit. Like, what are your thoughts?
It's it's unbelievable. Um, I have now gotten to the point where I'm on version 3 of a skill I'm building that figures out what you're trying to do, uses the system to build out a knowledge base, makes it world class, then figures out the app you want to build, then uses all the new capabilities you've been adding in the architecture to decide how you want to implement it, builds the whole thing, and tests it. So I'm literally just doing that rev of that last one right now. But so far, the things it can now do are extraordinary.
It seems to learn, right? Maybe
Yes.
it's almost
Yeah.
like am I deluding myself into some
You're not. What I went through was went to fix what we discussed yesterday, which was the challenge of Claude not being smart enough to realize this knowledge base is as smart as it is. And when you build a knowledge base based application, make sure you stay with the knowledge base. Don't keep taking the shortcuts. And that's really why I built the skill in the first place, because the knowledge bases are extraordinary, but the apps don't tend to follow them unless you absolutely hold its feet to the fire.
yeah, and that's
And that's
it.
the new skill I'm building that forces it to do that through the entire process. I'll share it once I get it done.
It thinks it thinks it's almost too fantastic to be true, and therefore it diverts or back to sort of the original
Over and
concept.
over and over again. It's like, oh, you have this amazing knowledge base, I'm not really using it. And the new strategy forces it to use it through the entire process, and it gets way smarter as a result. And then all the new things you're adding with the Sona and the hooks and all that really come into play.
Yeah. Yeah, so there's a whole collection of stuff that I want to walk everyone through today. Before we do, it's 2026, so that's exciting. I don't know where it happened to 2025. I guess I blinked and it's gone. But isn't that life, I guess? So it's a quiet day, and I know you guys could be doing other things. I figured we just vibe some stuff today. Anything else anyone wants to say or discuss, just pipe in and let me know. Um, this is me coding really. So if you want to, if you have any ideas, I'll show you some of the stuff I'm working on here, and we'll take it from there. All right, so just to recap a little bit, one of the things I discovered, and this is maybe esoteric, I don't know if that's the right word, is a concept called min cut. So, where did I put that? Oh, I'm in the wrong folder. I thought I clicked min cut. No, yeah, I guess I didn't. So what min cut does, okay, is in it's the concept of integrity. And integrity is the opposite of is it working? Is it about to break? And so you can think of it like the tension that exists within some of these systems in terms of are you stretching it too far? Is it going to panic at a certain point? Or is it going to lose? Is it going to break? Is it bad? It's almost like the negative element of any system. So a lot of that to do the negative, the worst case scenarios, if you will, requires generally a recalculation of the sort of environment or situation in which you're in. So these guys, Al Herrick and Hezinger and a few others, had a breakthrough on December 15th, where they came up with this algorithm that provides the ability to do dynamic introspection of this kind of thing called min-cut. So I'm like, all right, actually I'm not. I think it was the ChatGPT Pulse that suggested I look at this thing. To be honest, I hadn't spent much time thinking about this ever. So there, and it said this could be a game changer. I'm like, all right, ChatGPT, cool your jets here a little bit. And so, and I told ChatGPT that basically that I want stuff that's never been implemented before. And I really like the only thing worth using on ChatGPT these days, to be honest, is this feature of Pulse. Pulse is kind of cool because it seems to really get a good feel for the sorts of things I'm into. Um, so you can see a lot of min cut at this point, live agility scores, really nerdy stuff in my chat GPT. But if you sometimes it hits the sort of really interesting, elements. And then I can go look at it and see if it's something I'm interested in. So I think it was on the 15th or earlier, there was an indication that this was something I should look at. So yeah, so I using Claude Code, I basically did deep research into this particular approach of what this is, and you can see sort of some of that if you go to my gist. We'll go back here a few days. Root vector min cut. That looks like when this is when I first this is the research. I guess this is the paper I ended up posting. But basically, this is what I ended up building. And essentially, what that did, I'm not doing a good job explaining it. I should get ChatGPT to explain it better than me. Um, let's do a new chat. What the heck is this dynamic min min cut stuff? Simple terms. So let's get ChatGPT to explain it. It's a way to measure how close the system is to breaking while it's running. Okay, I guess I did explain it decent enough. Imagine your system as a network of roads, pipes, and nerves. Nodes are components, connections are dependencies or flows, and weight is how much capacity each connection has. Now, once I saw that, then I start thinking, that is one exactly what I'm kind of building with the vector system, this kind of graph meets vector space, where I have this sort of interconnected relationship between those components using graph structures. The connections are the sort of attention mechanisms that I'm using within that, where I apply sort of an AI to the interplay between the two. And the weights, well, the weights are the trainings, right? So I'm like, well, this already has all the stuff I need to sort of create a much more intelligent system that can learn and adapt based on its actual usage. So Mincut cuts the recompute time because it can as things continually change. So the bigger a network, a neural network, a traditional network, whatever, things that are interconnected, they're always changing, adapting. What this essentially does is allows you to do a real-time, 100% deterministic view of what's happening and what's going to break. So why this matters, I guess. Traditional monitoring watches symptoms, CPU high, latency spike, and error increase. That's basically every sort of telemetry system now. Dynamic min-cut watches the infrastructure dependency fragility, bottlenecks forming, and hidden points of failure. So if you want to think of it this way, it's essentially the basis of a neural of a kind of nervous system. So, and when you think of a lot of the work that monolithic systems have been doing, they were always focused on the concepts of kind of recreating a brain. But in this particular scenario, it's not about the brain, it's about the mechanism that happens in between your brain and the things your brain controls. My speech, or I guess it's a heliostatic system. It's like your heartbeat and the things you don't think about that just work, right? So you can apply those concepts directly to a kind of high-speed interconnect that works within that construct. So a low cut value system is fragile, a high cut value system is stable. And so that allows the system to feel. It feels the tension. And that is what guides the system. So when you go back to these other concepts, a lot of the reasons why our agentic systems work is an adversarial approach. The adversary approach basically is a self-criticism. So what this does is infuses that kind of adversarial element directly in the control systems of broad neural networks, language models, graph systems, whatever it is we're building, and allows us to measure that as it's being used and instantaneously adapt the system. All right. So self-learning systems that can prune and optimize self-learning and healing, create, the ability, and this is again, I'm trying to give credit. They hadn't implemented this, by the way. It was completely a sort of theoretical breakthrough. So then, and then I'm like, it was actually really easy to implement, so I'm not sure why they didn't implement it, to be honest. But anyway, as far as I can tell, I'm the first person to implement it. But once I had that, it gave me a whole lots of different sort of capabilities. So then I took it, I made a WASM out of it so I could run it directly in a browser. Then I did a transformer. So this is essentially a transformer model that applies this concept of min-cut, the sort of negative tension, the nervous system, if you will, of a platform, and then creates a mechanism to have understanding and essentially a sort of, it's attention, right? It's the core concept of AI applied to that particular sort of node structure. Hopefully what I'm saying is making sense. So again, it cuts the value, it creates a graph structure, it gives you different approaches to coherence and energy spiking. Spiking being particularly important. So spiking, when you think of how a nervous system actually works, is how it's working. When a signal goes from a neuron and synaptic structure, the information's flowing. The neuron is kind of the RAM. It stores the information. The synapse is the network flow of data, and the neural sort of, or the nervous system itself is the mechanism that handles the long distance communication. It's the WAN in your body, if you will. But each of those spikes, right? There's a bit of power that's used just to spike that particular thing and start that process from that neuron, or inversely from a touch, something you feel in your tips of your fingers flowing back to your brain in either direction. So and the other benefit to that approach is it's very, very low power because you're not doing what a GPU does. You're not looking at all the possibilities. You're just using exactly the spike in which you need the particular element. So lots and lots of different options there. And then I quantized it so I could run it on edge devices and do all kinds of other crazy things as well. So this creates a transformer. Once I had that, I'm like, all right, it occurred to me that this is actually a nervous system. So once I sort of thought, well, it's a nervous system, I devised a nervous system. So the the nervous system, this is where this is like way down the sci-fi sort of rabbit hole at this point. But I did the deep research using Claude actually to do this particular deep research, and I said dig into sort of how a nervous system works and the state of the art for sort of research in terms of creating a kind of artificial version of it. And what it determined was, well, it needed to be really, really fast, right? So it needed to essentially work faster than the human nervous system. And once you have that in place, it needs to stay quiet when it's not used. You don't want this thing constantly sort of churning through electricity and power because it's just not an efficient use of it, and that's not how the human body works. So essentially, what this thing did is it created a multi-layer nervous structure, lots of different elements here for predictions. This you're going to see EWC quite frequently in the stuff that I'm doing lately. What that does is it allows you to have long-term memory. So Chris, you mentioned you were working on memory. This particular algorithm is particularly important as part of any memory system you're doing. It's the same mechanism you do when you're training an LLM or whatever that needs it to sort of, reevaluate its state and remember what's important from what isn't. That is the algo. So if you're doing any kind of
Cool.
memory consolidation, that's what you want. And I've got it built in here. You can just take mine. All right. So now I'm attempting to create a nervous system, and so it converts continuous data into sparse events. Sparse events being that idea of spiking, only processing what's changed, 10,000 events every millisecond. So I'm running substantially faster than the human brain at this point, and this is just on CPU cycles. Instant decision via winner take all competition. So the winner take all competition is the idea that it goes. So let's use back to the analogy of a human. I touch something, I feel it. That's a winner take all scenario. It's going to a particular part of my brain, and the path between my fingertip and the sort of ability to feel and touch what I'm rubbing my fingers together or whatever, that's happening obviously in under 100 milliseconds, but it's sparse in the sense that it's going directly to that same part of my brain that needs to know and understand that thing. The memory is this sort of intersection between I've just rubbed my fingers together 5 seconds ago and I remember that, but I've been rubbing my fingers together my entire life. So there's a compression that's happening in your thought process. I don't remember every single time I've ever rubbed my fingers together. That makes no sense, right? And that would be an immense amount of data that I don't need. I just need to generalize the fact that when I rub my fingers together, I know generally how it feels. It doesn't hurt. It's just me rubbing my fingers together, right? So there's different ways for you to sort of take that and apply that to a hyperdimensional storage of that memory. So back to what I'm remembering, I'm using an episodic memory that says the things that I'm doing most recently are the most important parts of the things that I need to remember. And as time passes, be it really short or really long, it compresses that information and then creates a mechanism to remember just the semantics of the part of that information that's important. That I know that hot means it's painful, cold, too cold, also painful, somewhere in the middle is good, right? Those are generalized sort of understanding. It's doing the same thing and learning as it goes. So now that I've got this system that can learn, I can optimize the neural pathways from your fingertips to your brain, and so it creates a kind of muscle memory. The more the system does the thing, the better it becomes at doing the thing. Now, because I've created the system capable of understanding the contextual awareness of the information and patterns around it, if this thing sits inside let's say a prosthetic hand, the first time it's used, it'll be dumb. And I could pre-train it based on general sort of, other people using it. But let's hypothetically say everyone thinks differently and their nervous systems react differently than anybody else's. So rather than doing a generalized learning approach, which means that the prosthetic would work the same way for everybody, I'm saying here's this sort of baseline where we know that generally speaking, most people need at least this for it to work well. Then, as you start using the prosthetic, it starts creating a learned pattern that is an interplay between your actual nervous system and the virtual nervous system that exists within the construct of the prosthetic hand. So the two work in parallel. And so what's essentially happening, you got these events. I'm touching something, a reflex is happening faster than you can think. Is this something that's familiar, this semantically similar to something we've done before? Well, if it is, then I don't need to remember it. It just is what it is. I've already just kind of inherently know, and then I'm giving you an instantaneous response. Now, if it's something that's new, I've never touched fire before, I don't know what heat is, it's going to learn that, and it's going to make that loop. This entire nervous loop happens in microseconds and potentially I actually did this earlier and got a picosecond. I don't know if that's true because a picosecond basically means I'm working at the speed of the CPU. That might have been a quirk of my benchmark, so I'll have to dig a little deeper into that. But the reality is it's fast. So this is what traditional AI looks like. Tons of energy, trying to answer all the questions, slow, and you're creating a kind of inference. The inference is the problem with that is it's a kind of best guess. It's not deterministic. No matter how much we try to tweak a sort of language model, it's never 100% deterministic. It just doesn't exist. At least for this type of work, right? Because it's a kind of an interpretation of what that means into language. This isn't language. This is numerical kind of constructs of math and other sort of structures. So if you compare traditional AI is always running and consuming, right? And this is basically not doing anything unless you poke it, unless the spike happens. And it learns from the activities and fails silently and scales with more compute and does all these various other things. Lots of other features here, and I'm not going to bother getting into, but it's learning it's doing one-shot learning. All this stuff that I'm showing you now is all available as WASMs. So WASM allows me to take these crazy concepts, and if this was Python, this would probably be many, many megabytes of size, if not more, and would take a while. So I'm taking all this stuff and packing in these really tiny little WASM files that are literally 100 kilobytes. Some of these WASMs I've done, for example, for which one was it? The micro HW, this thing is like 8 kilobytes, 7.2 kilobytes for the entire HNSW vector search. So I can at this size I can embed those in pretty much anything, right? So I'm taking including your browser. So I've got all these components, and every one of these things I've built, in that, whether it's an attention system, have corresponding WASMs to it. So now, so the next version that I've been working of Claude Flow and Agentic Flow are using these WASMs as directly embedded within the structure of our clusters and swarms and things like that. But then it occurred to me, what if I could leverage that compute capacity now that I've got a mechanism to create structure and the interconnected relationship of these elements? Then I went and I created this thing called Edge. Where the heck did I put that? I think I got too many things here now. Oh yeah, here's the nervous system WASM for your if you're interested. But I created a system here called I gotta remember where I put it. Yeah, the Edge. And this is something I put out yesterday. Uh, where did I put that?
Search.
Yeah, I I I might be in the wrong. No, I mean I think I pushed it. Vector Edge examples Edge. Oh, I just wasn't looking hard enough. I was in examples. All right, so the Edge. So now I've described a bunch of things. I've described the idea of MinCut, which looks at the sort of negative tension and forms the basis of the concepts of a nervous system, amongst other things. This, by the way, it's also amazing for stock trading. And I've got that. I'll show you that here in a minute. Turns out that that might actually be the biggest breakthrough of the system itself might be looking at the negative tension within the stock market in different asset classes. We'll look into that. We're going to get into that in a minute. I just published that earlier this morning as well, but that seems to be doing really well. But before we get there, the idea of free self-learning AI swarms at the edge. So now I've got all these things that can build. I can build language models. I can do vector, latent, graph. I can do attention mechanisms. I get dozens of different sort of AI that can run really small in tiny loops on CPUs or GPUs. Then I'm like, well, what if I can put that just on the website and have that run rather than having all this capacity from the cloud because I'm cheap and I don't want to spend the money. I can leverage the federation capabilities that I've built that allows me to basically borrow the compute capacity of anyone that's currently visiting my site, but not for my benefit, for their benefit. So now I'm able to do self-learning and optimization and patterns directly on the client's environment without me having to see the information ever. That's important because things like HIPAA compliance, for example, if the provider never sees the data, then we there's a lot more we can do because there's a lot of privacy laws involving not being able to sort of essentially see the data and work with it, right? So if I want to aggregate tons of medical information, I essentially have to anonymize it and do all these things. In this case, I can literally just do all the analysis locally, and it's encrypted and never seen beyond the environment that's using it. Now I'm using a whole variety of different encryptions. A lot of the encryptions are inspired, and I know I'm gonna say a dirty word, blockchain and like cryptocurrencies. And I'm not doing this for the purposes of some bullshit cryptocurrency and some, rug pull. What I'm doing this is for the purposes of defining sort of, the interconnected relationship and the fact that most of these crypto outfits have been hacked so many times, they've gotten really good at creating systems that are kind of much more resistant to the obvious forms of exploit. So using the sort of that type of blockchain and crypto, specifically this kind of consensus mechanisms made sense. So in this case, what I want to do is have browser A, browser B, agent C, and so in mobile all kind of contributing through a P2P mesh. So back to how I'm doing that, we've got this idea of agent identity, and again, I don't want to know. I want this to be anonymous. I don't actually want to know who's contributing. And so for certain applications, this level of anonymity might not be great, but for what I'm trying to do, it makes a lot of sense. So then I'm encrypting it. I'm using again high-speed WASM, so it's really fast. I got vector, I got tasking, I've got trusted consensus, Raft, which is for sort of known teams. So in that case, you can create groups of people contributing versus kind of unknown, sort of structures. You got swarms, you got all the stuff that I love to do. It's way cheaper. Obviously, nothing. You don't have to spend any money for any of this stuff, right? So, and then I have this idea. So you guys a bunch of other sort of functionality, there's DAGs, and I get my embeddings for doing sort of the vector or even an LLM. I can share those. Um, so what does that actually look like? Well, I know you guys love dashboards, so why not create a dashboard? So in this case, and I'm still working on it, but on the right-hand side, we can see the actual, and I might be getting an error. Oh, it's connected. Looks like my website's closing too soon, but that's okay. I'll fix that in a minute. But basically, what's happening is you can go and you can contribute to these systems. Now, don't pay attention to my time crystal synchronization. The underlying tech for the time system uses something called time crystals, which sounds bonkers, so I might give it a more realistic name. Um, it uses a pi-based crypto structure, which is ED25519. But basically, I wrapped the actual ID in using a sort of recursion of the pi value. I don't know why. I thought it was cool to do it. I'm not really sure if there's any real reason other than it sounds cool, to be honest. Now, well, it's secure. It's just it's a gimmick. I'm basically taking the encryption key and making a compiled binary WASM, which is like 40 bytes or something. It's basically it's a key that feels like it has some weight, if you will. So rather than a text file or a random sort of set of words that you might do, I just made it a compiled WASM as the key to the system itself. So for me, it felt like a key. I don't know, like it felt like it had some digital weight. All right, so then we have different networks we can join. Now I'm bootstrapping the networks currently using Google Edge function. But what happens is once the system is big enough, the system can once you have a consistent amount of users on the platform that are basically it doesn't need these sort of Genesis nodes to keep it alive, but you need enough users, like any distributed system, that it'll exist beyond if no one visits the website or the website goes down, kind of thing. So to speed that up, I bootstrapped it on Google. All right, so in this case, you got different networks you can join, and each one sort of gives you different levels of credits. So you can generate these, I don't know, contribution credits. So the more capacity you contribute, the more you can get back, kind of thing. You can dream up different sort of scenarios here. I'm always just fooling around. Then we've got different WASMs. These WASMs provide different capabilities. So the WASMs are essentially the mechanism I use to deliver the application to the edge. So if you think of these as agents, and the agents need to do different tasks, maybe they might need to look at stock trading or do some form of analysis or whatever agentic structure it needs to do. This is a mechanism that allows me to deliver it and obfuscate it from the shared capacity of the network. I don't want people to see what's actually happening. I want the actual activities to be sort of, hidden, if you will. So that's what these WASMs that are doing. So these WASMs are again are kind of binary compilation of the task or application that is working. And these are kind of the broad components that you can use. And you probably are recognizing some of the elements here. So if I load it, I can load a bunch of these. And then I've got the different, and I can benchmark it if I want. I don't think I have the benchmark turned on, but and then you can, if you want to add this to your website. Now, I would suggest doing it in a way that's opt-in. And this is something I was sort of debating, and the ethics and morality of taking compute cycles from an end user. And this is the part that sort of I struggle with. So let's hypothetically say I'm a shitty web designer and I create memory leaks and recursive structures in the website, and I jack up your CPU uses to 100%. by mistake, or maybe it isn't by mistake. Maybe it just is. I just what I wanted to do. Now, is that ethical, right? If I go to a website and it's badly built and it uses more of my resources than it should, is that an ethical is that an ethical problem? If I'm running a video and it requires my GPU to run smoothly, is that something that I should ask to use? If I'm YouTube and I'm optimizing my video display using your GPU without asking, should they have asked to use my GPU? I don't know. They don't, right? If you go to YouTube and try to use YouTube, it'll actually optimize for your GPU. If you use Google Hangouts which is WASM, I might add, they actually optimize for your GPU and just use as much of their GPU and CPU as they determine they needed to use for that task. Now, inversely, if you pop this script on the page and you're now able to sort of, borrow the compute and GPU resources of the person who's visiting your website, are you obligated to ask and say, can I use that? Now, keep in mind, in the scenario that I'm giving you, the application is directly the reason in which they're visiting your website. And this, what I'm showing you right now, is kind of a more out in left field sort of share capacity kind of idea. I'm talking a single website and a single purpose, and then you're basically offloading the sort of intelligence itself rather to the cloud to whoever happens to be visiting that website. And that could be an LLM. That could be a self-learning system, a governor, whatever it is that happens to be doing. Now, the challenge I have here is I think the answer is it depends. I think if you're in a spot where you're leveraging their compute capacity and basically selling it to somebody else for their use, I think that might be problematic. And in that scenario, I would definitely suggest asking for permission, or maybe not even doing it. But if the application exists for the purpose of the application itself, then I would say maybe you have some sort of documentation. I wouldn't hide the fact you're doing it, but I don't know if you have to allow them to actually opt in. I don't know. Any thoughts here before is this
Well,
a rabbit hole?
just a quick question. Is the flip side of this, the example you were using earlier, if I'm trying to do something HIPAA based and they need to give me some of their medical records and I don't want to take those records off website, is that a scenario where you use this where this becomes the ethical, appropriate, proper way to do it? And you shouldn't need to ask because you're actually preserving their privacy by doing it that way.
That's a perfect example. And let's use medical is particularly well suited for this. So let's say you have a insulin pump, and the insulin pump, now using my nervous system and self-learning capabilities, is able to understand a much more fine-tuned version of how your metabolism works and how you ingest and digest sugars and other things that are explicitly and specifically tuned to your biology. Now, in that scenario, from a HIPAA compliance point of view, yes, you could potentially share that information if you chose to with your health provider. Now, and you potentially could even share that with the service provider, and given that they do that in a way that doesn't, that they don't steal it and use it other places. Now, what this also means is, if you're not comfortable with giving away that information, which for obvious reasons you should be, almost every company on the planet at some point has been hacked. And that's not saying you can't be hacked either, but it changes the attack surface from broad to very, very narrow, right? So you're kind of like one piece of a much larger puzzle versus one cloud of something someone can go after. But anyway, the reality is these systems now can be much, much more targeted to the particulars of you and your private information. And then we can take that a step further. We can integrate not just your metabolism and your insulin levels and whatnot. We can then correlate that to other parts of your biome, the other parts of your sort of conscious constructs, if you get that level of integration at some point in the future, and adapt all those things in parallel to each other, because they're all learning independently of each other and correlating those learnings through a kind of shared hive mind swarm-based structure that we've devised. That's what these sorts of applications are doing. They're providing that learning capability, that always on, always optimized, always understanding, learning, optimizing structure. And I'm just show I guess I'm showing it to you in a browser, but it doesn't. I think the real or the bigger opportunities aren't browser. They're likely they're going to look more like everyday sort of infusion of things. And so these are the things that I'm attempting to build. So the edge provides that. Then I've got the edge full or some of the more what did I put in there? No, I don't think I pushed that out yet. Um,
Hey, Rube,
so
I
the
could
edge.
see it's Alex. Happy New Year's, everybody.
Oh yeah, good to see you, Alex.
It's interesting you should say this because just in when you always start the conversation with like compute is so expensive, and it's like I can imagine a whole host of companies who would just use this for the practical sense of saying if I'm delivering a service to a customer, be it enterprise or consumer, and you're at Microsoft or you got a company with 10,000 employees, like why not take advantage of all of those browsers and all of those CPUs to like just selfishly lower your cost of compute within an organization, like just as utility, right? Because you've got all of those devices within an organization is just kind of one idea. And I also kind of think it's ironic as I was one of my side projects with the extra compute from Claude over Christmas was I just built a budgeting application that actually looks at like how everything is so expensive. Just on a lark, I built a budgeting application for consumers to actually like understand, hey, where'd all of my money go on my Visa? Because of all the money that I spend, why is everything so expensive? Right? And I actually built it so that it would be always like you're talking about, always on, always learning, but it has 2 points. It because we have a point to time today of how am I spending my money? Can I find better deals on the web to like lower my current expenses if it looks at my Visa? But also, what does this mean for my retirement? So I actually said if I don't spend, if I stop buying Starbucks lattes every single day, how does that impact my retirement in the future? Because for every $5 I save, it's $1,000 at retirement. Like having an always on system that can actually tell people, right, what's going on.
I like
Yes, I've integrated with Plaid, and in Canada we have Flinks that I had never heard of before to be able to pull in that data into the system that's always on and learning.
what's
That
Canadian one? Finks? What do you call it? Finks?
Flinks, I never heard of it
Flink?
before. Flinks. But that's the kind of financial data because I use Strava, I use Apple Health, like you said, everything gets hacked. So this notion of it being encrypted in the browser and you're processing your information makes a hell of a lot of sense if it's your personal financial information that you don't want anybody else to have.
Well, let's now you got me interested. So let's do that. So
Yeah.
watch
That's exactly
how
what I was going to go with, Alex, because I built a retirement solution over the week to do something similar to look at all the permutations, run it through 10,000 simulations, etc. And exact same problem. Nobody wants to load their stuff up because they're like, this is all of my net worth. I'm not going to tell you that. So how do
yeah.
you get them to believe it's really secure and will evaporate once they log off?
Well,
Well, first,
maybe you don't want it to evaporate. That I actually saw this guy, a Canadian on Instagram, talking about a financial planner, and I downloaded his Excel spreadsheet because I'm thinking about retirement. I'm going, okay, this is like the millionth financial product or Excel spreadsheet that I've seen, and none of the tools from any of the banks in Canada or the US are really helpful.
Right.
It's like, here, I'm going to tell you where the spending is. It's like, well, okay, but like the spending in my checking account and Visa have no relation to the performance of my stocks or the outcome of how much I need at retirement versus how I'm spending today and how I can save money. So there's three unconnected circles that actually should be a Venn diagram, and in the middle, it's the little doohickey that I was building. It's actually compiled on my desktop right now, and I've got a
all
little
right.
demo working.
Let's see it. I'm gonna start. I'm gonna attempt to do the same thing but you go if you want to show it.
Okay, I'll have to switch devices here. I'll have to.
And while you're getting that going, I'm gonna start baking a version of what you just described that exists only in a browser that takes the information from Plaid and then allows you to essentially learn and optimize on the resources from your browser only.
Yeah, I'm gonna mute myself here. Actually, I'm gonna hang up and I'll rejoin.
All right. Well, we'll see in a minute. All right, and that's what I like about Claude Code. It's like I'm just vibing here. Obviously, I'm not really sure exactly what I'm actually even asking or what I want it to do, but I know that I've got the tools in place that can do what I need it to do. So similar to for you guys, all if you're into what I'm doing, all you really need to do is you go into here and say using npx root vector. Now I've got different root vectors here. For example, the edge one and is npm at root vector slash edge. You could basically ask the same question that I did. Now, once you have these two, that's kind of the entry points to the ecosystem of these self-learning tools. And you can then just basically explore the capabilities of the system as I packaged them and made them. Now, I as the owner, I've got actually I'm just using directly the root vector environment here that you can see that I'm selected, but it doesn't have to be. You can just use your own if you prefer. If you want to use mine, just go into the repo and make a fork. I think fork is what you need. Yeah, fork it's probably the easiest way to do it. And then once you forked it, then you should see it show up after a minute or two in Claude Code. Then you can just say, build me something like what Alex just mentioned, kind of thing. All right, now so let's see what.
I can share my screen if you want.
Oh, sure. Okay, I'm gonna let this run for a bit. This is gonna take a few minutes anyway.
Yep.
All right, let's see what you got.
And let's find my screen, share, allow. Can you guys see?
Yep.
So in the background, quite literally, it has three parts. It has your ability to, this is just a demo from the homepage. This is just running on localhost. So the theory is you're going to put in your age, your income, your spending, and you're going to go through the whole process and kind of run a prediction. So you're going to connect Plaid or Flinks to pull in your banking info. You're going to, I've already loaded kind of test data in the back. So you're going to see what savings are happening. Like if I don't spend money on Starbucks, so it'll see a pattern. So it'll go through your statements and it'll say, oh, every Friday you're going here, or 3 times a week you're going there. And as a simple coach saying, hey, like what are the savings that are available if I just change my behavior a little bit? Because a lot of the stuff around the new year, it's like, hey, I've got New Year's resolutions. I want to change my behavior, right? I want to do something different this year. So it will go through, it will look for patterns and say, oh, look, like here's the amount of time that you're doing. So the second thing was I was friends or am friends with Derek Cito from Red Flag Deals and I know Ryan from Honey. Like there are a lot of people who look for deal hunters. So it's kind of like for many people, it's really hard to stop and go cold turkey. But what if, because we have AI and because we have Roove's wonderful tools, can we not have an agent that is going to look for substitutes to say, you don't have to stop, but why can't we use AI to go out and find um, opportunities to save money? So I can maintain the same behavior, but I can save money. The little motto up on top, save today, win tomorrow, is kind of like this little idiom that I came up with to say, hey, if you're here, like use this cashback credit card, like use this offer, use that offer, just as it's always scanning. So it goes through and activate deals. So theoretically, when it's done, and I'm stuck on this next piece, it's just actually fixing. Um, it will give you recommendations and show you how much this is worth towards the end. So if you're saving $36.67 a month, by the time you retire, just on this savings, you'll have an extra $1,000 at retirement, right? Or $1,200. Theoretically, it'll go to the next part. It'll say, hey, do you want us to automate some of these savings for you? And then the cross-platform magic is that it'll actually build and be smart and then always be on for you, kind of as your coach. So
And how you handle learning?
Um, so right now I'm doing the aggregation and I'm pulling in the data, and the learning is basically really regression analysis, looking at past spending behavior. in the
So
database.
it's not really learning. It's pattern matching.
It's pattern matching for now, and the learning will have to happen over time, right? You're gonna have to aggregate enough data to see what's going on. And secondly, it will have always on agents. So, and this is the thing, I don't want to spend the money, and this is why I think what you're doing is so interesting. I don't want to spend the money um, on the cloud services to save people money. But if you can put it into the browser like you're doing, then the person can activate it, they log
Well,
in, and it runs.
there's a the always on is kind of is my big kind of epiphany. And one of the reasons why I've been focused so much on my chip and my box and whatever is when you look at running an always on agent, like I've been using E2B for a lot. I like their service. It's relatively speaking cheap. But if I want to have one agent monitoring one thing all the time for a month using E2B and their cheapest plan, I think it's like $25. And that's like that's basically their most, I think, the most rudimentary option. Now, a lot of things involve many agents doing many things,
Mm.
right? So if I'm looking at financial related activities, for example, I'm looking at your stocks, your credit card, your bills, right there, that's three, at least three, probably more agents. So if I want that to always be running on my behalf, 24/7, looking and waiting and operating, that's going to be $75 US every month just for that one user.
Mhm.
Now, by doing that on my chip, I've got 256 cores or whatever it is that I'm going to be able to do, and I'm going to be able to run that all the time at no incremental cost. So what was once $25 is now 0.00302 cents per month for one agent. And that's probably that's a conservative estimate. It's probably cheaper and depending on duplexing. So, and I can run potentially 50,000 of those on a rudimentary box. So I can run 50 if I was to spend $25 times 50,000, obviously that's massively cost prohibitive. That's the type of opportunity that this kind of AI enables. I'm because I'm this the system is essentially dormant when it's not being used, spikes. The attention allows me to increase or decrease the megahertz or gigahertz sort of within the chip. So much like when you're in fight or flight mode, your senses tense up. You get focused. You do that thing. You can lift a car because you've been in a crash, whatever it happens to be. You can hit the baseball and a home run. That's the inflection of attention and focus, right? So the system works exactly the same way, and I can adjust the various sort of parameters and components based on that if and when something needs to happen. And I can say, well, this is beyond the capabilities of what this system can do locally. I've got this tiny dancer algorithm that can then say, well, I can go out to the cloud and I can go get the additional resources I need just for that moment, which means I'm not actually requiring the capacity all the time. I'm just requiring it some of the time, and I don't need to run it 100% of the time because I'm not using it all the time, which it gives you a kind of inflection between kind of back to the nervous system. The nervous system is always running, it's always watching, it's always taking the information and then allowing it to sort of understand and adapt based on that and make decisions. And that's what the cool sort of architecture here that this does. These systems sit alongside the traditional systems, like what Alex has described, and augments those. And it takes a regression algorithm and makes it smart. It takes the flow of information from a stock trading API and understands it. And that's the key difference here. It's particular intelligence. It's not broad, inferred, and unknown to itself. I don't know. I'm it's New Year's 2026. I'm maybe getting a little too deep here.
No, no,
Um,
listen, my son has a Raspberry Pi Minecraft server in our basement. So he literally did exactly what you're talking about for Minecraft because he had his own stuff in the cloud on his server, and he got it last Christmas, and it's been running for a year, and he has his friends logging onto this server, and he can do as much or as little as he wants. It has like so little horsepower, it's a very simple analogy to what you're already talking about, which is most people, um, like me, who aren't super technical, um, will default to basically using some kind of spooling in AWS or whatever to kind of have like a dormant or fighting the cold start issue with traditional servers. But the logic components are an entirely different story, right? Being able to call on logic and get smarter. And honestly, how many times do people look at their bank account? Like, why do you need to be running this all of the time, especially if it's you're basically tuning the output of this in an ideal world is me tuning an algorithm for each individual person.
Yes.
For those of you who aren't in Canada, I bank with the Royal Bank of Canada, and they have people in their branches who are investment advisors. Actually, sorry, they're not called investment advisors because they're not licensed agents. They're salespeople, right? So they're there to sell you what the bank has, and it isn't necessarily the best thing for you. So how can you marry these concentric circles? And each individual person should have their own personal plan because we're all different on this call. So this, I really like what you've built, Ruben. I can see exactly how it could apply here.
So, based on everything that Alex just said, and all the stuff that I've just been describing for the last whatever time it is, now imagine all that now can be done within the context of a single browser session that's devoted to only you and only you, and no one else can actually see that information other than you. So I can provide the service, but I would never be able to see it. And that's what's interesting here. So in this case, I just quickly you saw that I asked it, just to recap what we did here. How can we use the Edge system and the Plaid API to enable local browser-specific learning and self-optimization where learning AI doesn't leave the client browser, right? Really simple sort of prompt here. And it created you can see it created some Python and it's given me some, little diagrams of how it should work, pattern embeddings, Q learning. And be honest, it has a tendency to fall back to Q learning. I've got a whole variety of learning systems, and Q learning is not the optimal one. And I don't know why. Claude in particular likes to use Q learning. It's almost like it doesn't believe that I've been able to create better learning algorithms, and it defaults to what it thinks is what it believes to be the best.
So
It
how do you
isn't.
force that?
Well, we'll do that in a minute. I get appointed at my other learning systems.
Yeah.
But so this is the code. We got the learning system. We've got a demo HTML. This is actually see it work. We've got a README, I guess. This is what it's built. Pricing. Now, because this is on code, I can go to actually see this. So I'm going to view this in a place that's a little more. Actually, let me see where I put the files first. It put those in examples. It looks like it's in Edge docs played. So I'm going to go here and I'm going to go to my branches and I'm going to go to I think this was the one I just created 5 minutes ago, played. Yep. So now it was in examples. I think it said Edge docs example. And we're going to go to Edge and we go to docs. There we go. So this is what the system looks like. Now, IndexedDB is interesting. You're going to see that when you're working on browser-based, what IndexedDB does is acts as a local sort of, it's kind of like SQLite, but uses the local environment. So most modern browsers allows for data persistence. This allows you to persist the data just on the local device, be it a browser or mobile device or whatever. So when you're looking at creating user-specific sort of persistence, you're always using IndexedDB from the browser. Now and this is going to encrypt all this information, so it's not saved in text. Then this provides the ability to do that. Remember, I was describing the idea of kind of navigating to a particular point, going from your fingertip back to your brain. This allows for that navigation to happen ridiculously quickly using the HNSW. The spiking neural network means I'm not using more of the resources on your system than required. Q learning, because it loves Q learning. Local sensitivity, semantic categorization, and anomaly detection. So no data leaves, local only learning, it built this in like 2 seconds, right? All right. So here are the machine learning components. I'm gonna ask it what other learning systems we have. I actually know what other learning systems we have. Let's just give it what it needs. So I'm gonna go back to which one do I want to use? I got again too much stuff here. Um, ultra low latency. The I try to keep it organized, but there's a lot of stuff in here. Um,
How do you get it to use itself intelligently? Like whenever I've created this whole infrastructure, this whole framework, and I have to be very explicit about use this piece with that piece instead of saying go build it.
oh. Oh, you guys haven't, I haven't even told you about my coding system. All right, so I built a new version of RooFlow, CloudFlow that learns based on the environment. Let's see here if I can show you that. So you see all these things here. The system is, I'm gonna put this out into CloudFlow here probably in the next few days. But basically, tell me how the self-learning system in at at settings.json works in simple terms. All right, this is so all that stuff I was showing you, I've actually created as hooks within Claude, which automatically works in Claude Code Web as well. So basically what I'm doing is I'm this is running in the actual environment, but there's an NPX you can do as well. If you want to try this today, okay, so before I show you how to do it, I'm going to tell you what it does. So the self-learning configures a feedback loop that learns from your coding sessions. Here it works in simple terms. Every time you or Claude do something, the hooks run before and after, record what happened, track it if it happens, and learns for the next time. So it's essentially the more I use the repo, the smarter it gets, and I've got the mechanism to actually pre-train based on the repo. So if you so it's going to go in here and do various forms of learning and optimization. So in this case, I have 872 memories and 5 patterns mentioned based on this session alone, just in this one session that I've been doing and today. So then we go here. If you guys want to try it, you're going to type this. You're going to type root vector, and you're going to type hooks, and then you're going to do init. Now, if you do init, it's going to overwrite your JSON. No, I added a force. Be careful, it might overwrite your existing settings file in Claude. But if you're interested in what it does, you can type help. And now this is the entire structure. So I've got all the various capabilities for editing, trajectory, and diff, and everything you'd ever want, graph and clustering. Now that all is happening within the structure of the system. You can pre-train. So if you're doing a new, if you've got a new repo and you want to sort of have it understand how that repo works, you can go and type pre-train. The pre-train allows you to look at the Git history. It allows you to look at different structures of your code, and then it trains the system based on everything you've ever done to that repo, which is amazing, I might add. It creates semantic self-learning optimization of the repo itself and all the code and how you got from where it was originally, and that could be years. I pointed this at a repo that was like 10 years old. I think it was like some PHP. It was WordPress. And I pointed at the WordPress repo and I basically said, train it on everything it's done over the last 10 years, every contribution ever made. And it found, I don't know, I gotta find where I put that. I gotta spin up but basically it found all these crazy things about it, like, all the errors it gave me an itemized breakdown of basically the worst developers and all the problems that person did. And the first thing I thought of, well, I could point this at, a potential hire and say, tell me everything there is to know about that person's code over the last 5 years. Are they getting better? Are they better coders than they were 5 years ago, kind of thing? And you do all kinds. But basically, this is what this is giving you. So if you're interested in using it, again, all you're going to type in is init. And then as soon as you go back to using Claude, it'll magically just start using it because Claude uses the same hooks. So as you're sort of working and doing whatever, it'll get smarter. That is going to form the basis of my next version of Agentic Flow, which I took and made that even more crazy. Let's see. Oops, wrong window. So Agentic Flow is basically the core piece of the of Claude Flow. This is where all the intelligence lies. So I've taken all the pieces I've been showing you this morning. See, I got colorized this a little bit, but I've got patterns. It's learning, it's optimizing, and if you're interested in using that, the latest version of Claude of Agentic Flow is MPX Agentic-Flow at alpha, and that also has an init. I'm going to see if I'm actually in the repo, so we'll see what happens here. All right, let's 2 points, alpha 832. Fingers crossed. All right, here we go. So what this allows you to do is run it with any of your browsers. You've got, the ability to deploy to E2B. You'll soon have the ability to aggregate across my little Bootstrap, contributed compute resources, all that kind of stuff will be built right in here. But this also has, and again, this is verbose for the actual agents. I don't expect anyone to read all this crap. But you also have the ability to do the init here. So if you're I think it's let's see, I think it's hooks. Oh, what's it doing that again? It's weird. I'm still working. This doesn't have as many things exposed. If you want all the bells and whistles, you're going to use the RuVector hooks. That's got everything under the sun. Now, the benefit to using this implementation is I'm using a MemoryDB versus JSON files. So what that means is, if you go here to intelligence, you're basically seeing where's the file? Gotta find it. It's basically using a giant metrics file. I gotta find wherever the data is. Here it is. Yeah, so this is how it's storing it. This is kind of the most raw. So as I move up my sort of chain, I go from low-level infrastructure to more packaged to, so this would be, so RuVector is kind of the bottom of the stack, if you will. So that's why I keep these things exposed as JSON, because you can take this and you can put it in any format you want. But these are all, being, you kind of see the internal data. You can see how it's learning, iterations, the weights, they're all exposed. You can see how I calibrate it, metrics, uncertain stages, whatever. I haven't found any of those. This one is almost 9,000 or 8,000 lines of stuff. But that'll give you, and you can use it to train as well. I think I made this available as well. I published this so you guys can go to the folder and sort of see how I do it. All right, so I kind of went off track there a little bit, but here we are. Simple explanation. What does this thing do? It lets you connect to your bank via Plaid and get smart insights about your spending, but all the AI smarts run inside your browser, not on some server. Normally, financial apps send your transactions to their servers and analyze it. This is basically AI learns your patterns here, insights here, transactions, nothing leaves. And you can see how quickly I created this thing, right? Literally, it was a minute.
Rube, I guess the question is, so what happens when you log off from that session? What happens to the knowledge, what it's learned? How do you go back? How do you resume that a day later, a week later?
Yeah, it's persisted using IndexedDB. So basically, what IndexedDB is doing is saving that information to your local cache in that only you on your hard drive has access to, right? It's encrypted or whatever as well. But essentially, it's stored locally. So when I go to this site, I've already signed up here, and I go to my identity just as an example, and I hit refresh. and I go to the my identity, it's still there. It still remembers the things I had because I'm persisting it. I've got some errors at the moment I gotta fix, but you get the idea.
Okay. Thank you.
So it doesn't leave. So if you want to join the SETI at Home project, same idea.
But I just had a question. I had the same question. What happened if the person just have a problem with the laptop or a computer, have to restart their computer, or if I lose the computer, how can we back up this
Well,
information?
it's gone. If you lose your computer, it's gone. And if you lose your key, it's gone. If you but if you know, hypothetically, we could save all this information back to a database. Now we could
Right.
anonymize it. I could include a WASM that acts as a PII anonymizer, right?
Could be like a part of the service that you offer that make a encrypted backup in case that you have any issues, then you can bring it up by the key, maybe
Yeah,
something like that.
exactly. That's exactly how you do it. And so you might give them a private key, and then only that key unlocks the data, even on the remote environment. So
Yeah. Like a
to the
wallet.
provider, yeah, the provider just looks like a bunch of random numbers and letters. It's meaningless. But
Correct.
if you've got the key, then it becomes meaningful. So in this scenario, this is how the information is being saved. AI learns the patterns in memory, so I'm doing all the magic and learning and doing whatever using your resources in memory. Then I'm storing those patterns, what works in this case Q value because it loves Q, patterns and spending averages, embeddings. I'm embedding those in multidimensional space and organizing it. So what's stored Q values under budget on food and gas is good. This is 1 kilobyte. Here's the patterns. Average coffee purchase is 550. Embeddings represent the similarity, like what's related. Temporal weighting. Spend more on Saturdays. And this is has so it's all very tiny. The drawback is you've got less space, but this is all lightweight text, and I'm compressing it, so you're never going to run out of space. Um, so now I say, how can we take this further? Think exotic. Loves the word exotic. We'll see. We'll see where exotic takes us. I always do from practical to exotic.
Does UltraThink help exotic get more exotic?
I think UltraThink mostly overthinks. My approach is rather than ultra thinking, I'm ultra learning, right? And to be honest, that is something you bring up an interesting point. I was actually thinking of including not just hooks in this system, but this is the agentic flow, but this one. What I was thinking is adding the ability to have certain in commands like ultra think. So what I was thinking of doing like if you say something like ultra remember, then that kicks off a series of actions that can then sort of optimize based on that memory process and review and dig and do various sort of secondary learning when you mention that just in a run of your given interactions with the system.
Ultra
So similar
skills.
ultra skill or something, yeah. So yeah, let's explore that for a moment while I'm at it. Okay, so if we give me some ideas on how we could include certain, what do we call these, like hidden commands that invoke additional learning skills and background workers if someone enters the word in a Claude chat session. For example, ultra learn. That then invokes a series of more in-depth learning and optimizations relating to the request. Don't implement. It's likely part of the hooks system. All right, that's an interesting idea. Ultra learn. Thanks, Stu. That was a good idea. We've got everything we need, so now I'm just gonna figure out how we can do that. All right, so while that's doing that, let's go back. What's happening here? Let's look at the exotic. Boundary pushing ideas. This is the sort of stuff I love to do. All right, so we got federated financial swarm. Browsers share patterns, not data, via P2P to collectively learn. You can see that I've already built that. I should have gave you guys a demo earlier on how the P2P system works. So browser A, browser B, browser C shares pattern and layer. Coffee shops average $5 to $8 globally, no individual data exposed. So back to Alex's example, he could create a mechanism that aggregates across all the users of his platform without sharing specifics, but generalities and the optimal learnings from each. So you're proving financial responsibility without revealing numbers. You, landlord, I can prove that I've stayed under budget for those 12 months, though showing my actual spending. It's interesting. It's like a secondary form of like credit bureau. My credit sucks, but for the things you want, for the things that are meaningful, I pay my rent on time. I but I do owe 5 years in back taxes or something. I don't know. Um, Neuromorphic spending brain. Oh, I like the sounds of that. Use actual brain inspired computing for pattern detection. Spiking neurons fire when? Usual time of day, unusual merch in a category, unusual. This is exactly what we're talking about, right? This is me controlling the nuance of the algorithms that control my life. Why does my credit card get shut off when I take a trip to Mexico? Like, is it not smart enough to see that I bought a coffee at the airport? I got some pesos when I got to Cancun. Like these are all obvious signals that I'm on vacation, yet somehow or other the credit cards still don't seem to get it. Right. So, but this would allow me to say is I can control the nuance of the algorithms that are in my life. So it's optimized much more specifically to me and the things that are meaningful to me. And if they aren't, I can then make modifications to it. Hyperdimensional money embeddings. 10,000 dimension vectors that capture semantic meaning. Coffee weekends, Saturday morning, Starbucks, coffee, crazy icon, okay. I'm not even going to try to pretend I understand that one. Quantum inspired periodic structures for detecting temporal anomalies. Whenever I hear temporal anomalies, I think of like Star Trek. Captain, we've got a temporal anomaly. I don't know. Anyway, time crystals detect rhythm, breaks, and spending patterns. It loves time crystals. And if you dig deep enough in any of the stuff that I'm doing, time crystals are going to keep coming up over and over and over again. Keep in mind, we've pretty much cracked the ability to predict the future as long as it's less than 1 millisecond. That's why this thing keeps coming up. But I know I sound like a maniac every time I say it, but I'm pretty sure we can predict pretty much anything as long as it's in a small enough time cycle. Stegmatic budget. I'm not pronouncing that right. Ant colony algorithms to find optimal budget paths. Pheromone trails strengthen on successful paths. Okay, that's pretty out there. Want me to implement these? I should just start with like ZK proofs, revolution practice for credit checks. Well, that's kind of cool. Now, tell me more about that. Oh, did I skip that one? No, there are zero proof budgets. Yeah, this one sounded cool. You prove you're financially responsible without revealing numbers. I think that's of all the ones that I've heard, that sounds like the most practical. So I'm gonna say, let's explore in more detail. All right. While that's doing that, let's jump back to our other one. What are we doing here? All right. Hidden command ideas for enhancing learning. User prompt. Oh, by the way, this all works on Windows. You'll be very, for the Windows users, if you want to use like a flow system natively in Windows, you can do this. The init works. I've been using it. All right, back to what we're building here. The user prompt hook already fires on every message. It could scan for triggers, words, and then invoke special modes. User types ultra learn and how the authentication works. The user prompt hook detects ultra learn, spawns background workers. Background workers are important. And when I'm doing a lot of the stuff now, you're going to notice that I've moved to a background worker approach. And this is both for browser and for CLI related activities. These essentially allow me to do non-blocking activities independent of the initial stream or sort of flow. And it's much more effective for parallel applications, especially learning. So if you need to have multiple things learning in different parts of the same structure, that's how I'm doing it. All right, trigger words,
Talk
ideas.
more about that. Is that native to Claude or native to your work?
It's native to my work. I'm using the concepts of background workers from like I think in the browser it's called a web worker in JavaScript. It allows me to invoke secondary processes that are independent of the web page itself. So think of like I need to do a whole bunch of different, ongoing learning activities, but people are changing the page, right? They're clicking around and doing stuff. I can create those web workers to not be disrupted by the changing of the page, if you will, right? Because if you're on a web page, people are clicking, they're leaving, they're doing. I can essentially invoke that, get it to do its thing until it's done, and they could have long left the page, which is useful, right? If you're learning, and you're only on my page for 10 seconds, there's not much I can do in 10 seconds. The web worker allows me to keep doing that for 15 minutes. Now, back to ethics. Is it ethical for me to keep doing and thinking if you're only on my site for 10 seconds? I don't know, but the functionality definitely works, and I'm able to do it easily. So these are all questions that we're going to have to ask ourselves, I guess. But I'm using the same concept within the CLI to invoke things that are happening independently of what you're seeing in Claude Flow. And it sits outside of of Claude Code or Claude Flow or whatever. All right, so we've got deep dive. Yeah, these look pretty cool. Analyze your request against past. So pattern miners, ultra learn triggers spawn agents to read related files before you ask. Build dependency graphs in memory. Cache likely next questions. Context expander, silently research code base for related concepts. Build semantic clusters in vector memory. Read to inject context. This is all pretty cool stuff, actually. I think I'm going to totally do this. Detect triggers, compound triggers, ultra learn plus remember, deep learn and commit everything. Oh, this could be an interesting little thing that I've just stumbled into. Yeah. How can we take this and make it more useful? Yeah, let's see where this rabbit hole goes. All right, while that's doing that, where are we at here? All right, so we checked in here, we're looking at ZK proofs. Now, if we're going to use a ZK proof, the ZK proofs, I'm not going to try to explain a ZK proof, but basically they're highly optimized by GPUs. So I know that. So what I might do for the ZK proof, depending on the level of sophistication, I could implement a WebGL or WebGPU interface to borrow the GPU resources from the client as well, which would work amazingly well on a mobile device. Those GPUs, the mobile GPUs are awesome, like the chip in an iPhone or something. Traditional credit check asks, can you afford $2,000 a month? You must reveal your income, bank statements, transaction, everything. Risk data breach, discrimination, ZK solution. Landlord asks the same question, and you prove landlord only learns that you qualify, doesn't see any numbers. Now the problem with that is you need a trusted intermediary. Like this is all great and all, but somewhere someone needs to provide that layer of trust. which is back to what I think Alex was describing. He's the website you trust in that scenario. But it's a cool architecture. So you got the played data, you get the ZK circuit compiler as a WASM, you got a proof public, never leaves the, and unfortunately you can see that I'm playing in the area just adjacent to crypto and cryptocurrencies. But to be honest, you don't need a cryptocurrency for any of this stuff. You know, you don't need some random tokenized whatever to do this. You just need the crypto, the cryptography itself. Provable statement, income, rent affordability, no overdraft, savings buffer, budget compliance, payment history, debt ratio. Okay, it looks like it built it. Oh, that's cool. Okay, keep going. Where are we at here? How can we take this? Hopefully you guys are following my back and forth between these two different things we're working on. Okay, this other thing we're working on is making hidden commands actually useful. Raw concept is cool, but here's to make it practical. Just detecting ultra learn is gimmicky. Real usefulness comes from knowing when to suggest them, not requiring memorization. What's the skill system? Composable behaviors. It seems like it's the skill system. Isn't this just the Claude skills system? I guess it's yeah, it looks like I might be able to use the skill system. So they're suggesting mode plus verbose plus different structures. Instead of magic words, detect intent patterns. User, I keep getting this error. I don't understand why. System detects frustration, repeated failure, and comprehension gap. Well, definitely a comprehension gap for me. Auto suggest, would you like to activate deep analysis mode? I don't understand. Explain. Okay, that sounds interesting. Stackable micro behaviors instead of big ultra learn, compose small behaviors. That's where you mode x plus y. Persistent mode states. Measurable outcomes. The hook suggests modes based on what you're doing. Isn't this just a skills system? Oh, I'm right. You basically describe skills with extra steps. Okay, thanks, Captain Obvious. What would actually be different? Explicit commands, only the novel parts. Use skill. If you just want trigger words, use skills. Okay. I want to invoke background workers that do more in-depth learning analysis and optimization, I guess, based on certain keyword triggers. What's going on here? All right, I've implemented a full ZK proof system for financial statements. Now it says it has. This is the same cryptography used in Zcash, Tornado Cash, Polygon something or other, bunch of random crypto things. Review, check for security issues, benchmark, and optimize. Now, the reason I'm asking, I always ask for security reviews. This stuff is out there, and I have no idea specifically, what vulnerabilities they have in areas that are novel. But the other part, when you ask for a benchmark, the benchmark basically makes the system try each of this. It doesn't just try each of the capabilities of the system. It pushes those capabilities to its maximum sort of usage. Once you've done that, you can you can then optimize it. So a lot of what I'm doing at the point where it says it's done, the first benchmark after something new is generally going to find the bugs. So it'll fix those bugs in a way that's more meaningful because it's using the system, not just doing tests about the system. And then it's optimizing those things, right? And at which point I can then figure out other things to do with it and optimize it or take it down other rabbit holes. But you can see that I'm doing the security code. This is going to take a minute to do whatever it's going to do. All right, let's go back to this other one for a sec. What do we got here? All right, background workers that run while you keep chatting, not skills. You ultra learn how the auth system works. Hook detects ultra learn, spawns background task agents, keeps chatting, workers run silently. Okay. You know what? I think I might do this. I'm not sure if I want to do this in this one. I might do this in my agentic flow system. It seems more aligned with what I'm doing there. Give me some ideas on how we can use the various agentic flow capabilities and the RuVector capabilities to along with our hook system for the following. Yeah, I think this system might already, I think I've already built the background workers into this system. So it makes more sense for me to do it in a place where I've already built it. And I can, and the benefit to this system is I'm using agents. So I'm using the new agent, the Claude Agent SDK that they updated a couple weeks ago. So that's all been integrated, and that includes a whole bunch of hooks and intent capabilities. So I think I've got everything I want right there. So what I might do inversely in this one, could we use npx agentic flow at alpha? I'm going to use npm for that to help with the workers, since this SDK already includes this capability. All my things intertwine and interconnect. Agentic flow is almost entirely, all the logic and reasoning capabilities for this is almost entirely RuVector, but all the agentic structures are independent of it. All right, let's see what this says. So one feeds back to the other. Both use the same. Both are dependent on each other. But this is a powerful concept. Here's a concrete implementation idea leverages our existing capabilities. Ultra learn. So this is how it detects different words. It's just a simple pattern matching, probably enough. This is the AgentDB store. All right, ultra learn. It spawns research. Store summary for quick. Right. Memory-based results surfacing. Yeah, it looks pretty good. Now, before I do that, I'm going to say, how can we optimize and improve further? Create a detailed plan in /docs. I don't know what my folder structure looks like here. Docs, no, it's agentic flow, docs. What are we calling this thing? We'll call it hooks. All right. We probably don't need a subfolder. I'm going to use the ultra thing. There you go. Some ultra thing for you. What do we got here? Now we're back to RuVector, and we're saying, yeah, it's much cleaner using existing infrastructure instead of building from scratch. Swarm initialization, agent spawning, task orchestration, memory persistence, ultra learn, auth system, display triggers. Now the real question, since I'm probably going to build this in a minute over here, I'm not going to implement the thing twice. I'm going to implement it here in a way that I can use it in the other system here in a minute. So because this is basically my kind of core library for doing complex flow and agentic systems, right? So I want it here. This is more useful for me for other things I'm building. So when I'm building agents for my customers, I'm using agentic flow, generally speaking, to do those agents. All right, that's gonna do that. That'll take a minute. Where are we at here? Oh, this is still running. Doing too much.
Benchmarks take a while, we would imagine, right?
Yeah, the benchmarks, and that means it's working. Let's take a look what we can see here. It's so the WASM bindings for zero knowledge. That in itself is kind of cool. I can do zero. I will be able to do zero knowledge financial proofs using a WASM in the browser. So when you're building crazy complex things with at least my RuVector stuff, I'll always ask for a version of it compiled to a WASM that you can use in a browser if you're doing a browser-based application or whatever the environment in which you're building it for. You know, if you're building it for CLI, you're gonna have to compile specifically for the CLI. But tell it generally what you're doing, and that takes this and makes it super small. This WASM will end up being like a few kilobytes. It'll go from many megabytes to kilobytes, and with no dependencies.
And does it automatically know to run the WASM version if you have a WASM?
Well, you have to tell it. So in the case of like my Windows, I have a cascading series of WASMs optimized for different environments. So I'll compile for like Windows versus Mac versus Linux, or I'll compile for CLI versus browser. And then I'll gracefully sort of go through and detect and then serve up that particular version for whatever environment it's currently running. So if I'm doing like a shared network here, I might, this JavaScript that you can include on your website or whatever, this would have the ability for you to go and auto detect that it's, browser, or if it's not, it's maybe I'm using it in the CLI or something, depending on the include. What else we got here? Still looking at that.
I just thought of an interesting thing that could be totally random. So as you're talking about stuff happening in the browser, which is temporal and immediate versus stuff that might require persistence, all of us are familiar with the price of gas. And it's a perfect example of like, um, there are websites that track gas prices. If you have something running in the background on somebody's phone, right, as part of this exercise, as you're talking about the WASM, like, do you compile, an iOS app for the consumer that's kind of like a little agent that's using this on behalf of the consumer to say, oh, by the way, we've noticed over the last month that you have the following, or whatever. We analyzed your data. We tend to notice that you fill up on gas on Mondays. Are you willing to change that behavior? Or you have it running on the phone as an agent in the background saying, what things could be running on your phone using the code, right, the algorithms in a learning sense, whether it's financial, whether it's medical, if it has access to your health data, right? Because if you do a permissions with Apple Health,
I
right,
already
the other health
I already
apps.
built that. I already built that. So that's what this WASM does.
Mhm.
So this WASM is again RuVector as well, but this WASM is explicitly been compiled for iOS, both the iOS browser and native sort of development environment. So I've got the ability to do privacy preserving learning based on direct integration with health, location, calendar, communication, and app use. So yeah, and this thing's tiny, like kilobytes as well. So it could correlate your health to the location, or
McDonald's.
yeah, whatever it needs to learn.
Yeah.
That would be an incredibly useful app. I mean, a bunch of us have different things that we track, but all the nuances aren't there to put it all together and tell you what it means. This would be a great example to come up with.
Yeah. And the last thing I didn't get to,
Oh
I
yeah,
had built.
Well Trader.
So for those that are interested, I did. You know how I described sort of am I going to build it here or there, right? I could have went to NeuroTrader and said, build me the root vector integration and self-learning directly in NeuroTrader, which I didn't do. I inversely went into root vector and said, look at the NPM for NeuroTrader and all the related capabilities and optimize against it. So one would be like bottom up, the other is kind of top down. Either way, it's a good example. This is just a good example of how you can use this tool along with other things you've already built. So basically, combine these two things together and tell me what you can do. So in this case, what I've done is I optimized the learning capability, the state-of-the-art machine learning capabilities directly against it. So now I've got different types of this. The Kelly Criterion engine is used mostly for sports betting. Um, I don't, again, ethical, whatever. The sports betting stuff is, as far as like making money, one of the easiest ways to do it with this platform. You know, because there's so many different verticals you can now bet on in sports, and most of them are very, very easily predictable. I'm not predicting in this scenario who's going to win the game. I'm predicting in a short order who's likely to score the next goal or sink the next three-pointer or the other sort of the parlays and other statistical anomalies that exist within these games, which are actually really easy to detect. You know, and if there's 6-on-6, there's not that many mathematical things that could happen in the next 5 seconds or 5 minutes. So it's looking at that. Then we've got the sort of transform predictor. This is looking at a kind of data-centric prediction, volatility, other things. Now, what's important to look at when you're looking at this is the fact that we now have that brand new algorithm. Where is that? MinCut. Oh, I gotta do a better job of documenting that. But basically, what the MinCut does is allows you to look at the sort of jitter and noise that exists within the structure of the trading environment. And then inversely, it's not looking for optimization. It's looking for almost like risk mitigation, which works perfectly for stocks, right? It's basically telling you what's about to break, which is forms a whole other form of technical analysis. Portfolio, we've got sentiment, alpha pipelines, trading pipelines. You've got CLI interface. What this is really trying to do is show you how to quickly create sort of trading related activities. This can run all the time, which is important. One of the biggest challenges you have with real-time stock trading systems right now is the fact that your options are essentially running on your local machine, probably a Mac, and have that run all the time, which is not a bad plan. It's not that expensive if you go buy a decent Mac. The other is you can have these things running, basically all the time at low cost, but you can do millions and millions of agents looking at every possibility, simulating everything every second of the day. That is not going to run on a Mac, right? That's going to overload the Mac quite quickly. So what this allows you to do is use things like these kind of chips or a Raspberry Pi or whatever to do that at a massive scale. It kind of mimics the idea that we hear sometimes of quantum, where you're like, answer all the possibilities of a given answer and do it all at once. This isn't going to be instant, but it's going to allow you to do in parallel billions and billions of variants of the particular problem you're trying to solve and give you the optimal solution. And that's happening in milliseconds. So that's the part so it's not happening. It's not instantaneous, but it might as well be instantaneous. It's happening in milliseconds. So that's how we're doing these sorts of things. We get news-driven trading. You can see here the throughput. Now, the important part is the speed, right? Kelly, so this is a single bet. So you're operating way faster than the context of the trading environment. No environments are that fast. So that's something to keep in mind. But you can build up those. So what's really important isn't one bet, but many, right? How do the things correlate between them? What's the interconnected relationship between A, B, and C in ways that are not obvious that I can exploit to make a few bucks in the next 5 minutes? Same with sequences. You can see that this is really, really fast. And this is streaming. So you can do thousands a second kind of thing. Attention applies to what's important at a given point, sentiment, that kind of thing. Production readiness, well, that's me. That's arbitrary. Comparative analysis. I'm way faster.
Yeah,
Basically.
the issue with trading, and the one thing that's really well known is that the high frequency traders were putting their data centers as physically close as possible to the actual exchanges to shorten the route for the actual packets, which is crazy. But I can
Yeah,
totally see this. I can
I'm doing
totally.
that. I'm doing the same thing, but I'm because I'm predicting things faster than speed of light. I no longer am constrained by the speed of light between two locations. So that only works because they were using monolithic style machine learning models, right? So most of the latency that they were seeing wasn't actually revolving around the 16 milliseconds it takes for information to flow between New York and London. It was the fact that they then had to work within the 100 to 200 millisecond window that exists at the point in which they got that data, right? So I'm getting the stock information from London, and there's an arbitrage opportunity. I have 100 milliseconds to make a decision whether or not I want to execute on that arbitrage. Now, that arbitrage opportunity, I'm able to now front load that because I'm actually able to predict with 95% for confidence what the next bit of information is going to be floating across from London to New York. That allows me to then use that window that sits beyond the speed of time, the speed of light, to make a whole multitude of different decisions before my competitors even got the information that they are going to make the decision on, which we know is roughly about 100 milliseconds. In the time that has gone by, before we've even got the data, I've already made several thousand calculations to determine what the optimal solution to that problem is. And I'm now capable of making the request for the trade before my competitors even got the data itself. Right? Which is crazy. But the most interesting part of the whole story here is it seems to work because it's learning, it's optimizing, it's getting better. So much like a baby, the first time you're using it, it's okay. And you're gonna notice, anyone that's done any of the neural trading stuff is gonna notice going from paper to real money, no matter how much paper trading you do, there's always variance. And I'm not really sure why, other than there seems to be this weird sort of observation paradox. It's almost like somehow or other the system knows that it's fake, and it operates differently when it's paper trades versus like real money on the line. And I, for the life of me, can't figure out why that is, but it's definitely a thing. So once you're comfortable with that sort of phase of like optimization, spend a few hours or days optimizing for it, you usually overcome it, and suddenly you're in a profitable position. Um, that's what the system does.
Can we spend some time going through that a little bit more in depth, like showing what do you mean with your stock trading examples, or what do you mean with your sports betting examples? Because we understand it conceptually, but the devil's in the details, and this is not a place where you want to get this wrong.
Yeah, no, I hear you. Not today, but
No,
yes,
I understand.
um, we can definitely do that. And there's some folks doing pretty well. Again, I'm like the people that do well with this, just to be completely honest, are people who know finance. The people who that lose are people that don't know what they're doing before they started and thought that this was like a magic solution to all their problems to make money. And oh my God, I didn't make any money. Well, that's because you don't know what you're doing. And that doesn't change the fact that you don't know what you're doing. It just makes it faster at doing something you don't know. So the trick here is learning and understanding and being critical and self-aware of the things you don't know. And those are the people that seem to do the best in at least what I've seen. And I know this is terrible because kids shouldn't probably be doing this, but some of my son and his friends using this platform, and they know they should be 18, blah blah blah, hypothetically, but they're young and inquisitive, and they're doing great with this stuff. That's how I discovered all this sports betting stuff. They're the ones that showed me how to do it, and so that says something about like maybe a combination of ignorance and aptitude.
Yes.
And are you
And I
going to
Oof.
enhance the neural trader piece with what you learned here? Because you said you pulled the NPM and neural trader into here and had it do it. But are you then going to push that back to the neural trader side so it
Yeah,
becomes
will.
root vector infused and intelligent? Because that's a big monumental shift.
I think what I'm going to do is I'm going to use the agentic flow as the core. It's just easier to manage, and my root vector, it tends to be the kind of the bleeding edge of the bleeding edge. So this is going to be less frequently updated, right? I might go weeks before doing upgrades on this, where root vector changes, and when it follows my GitHub, we'll see it changes multiple times a day.
Mhm.
But so that's one. So once I have like trigger systems, maybe the trigger systems could also include the ability to do triggers on trading and insights and correlation and temporal dynamics and all that kind of stuff. That'll be done through this. So if you want to spawn 1,000 agents to run and do your trades for the next year, this system does that, and I'll integrate this directly into the npm neuro trader system. Now, if you are interested in using Neural Trader, MPX Neural Trader, it's a few weeks old. It uses all the agent DB stuff, which led to root vector. So it's not bad. It's just if there's a scale of smart, it's super smart. It's just not as smart as the stuff I've done in the last couple weeks. So yeah,
I
Neural
know how
Trader
I'm
is
gonna
all
get
you
my I know how I'm gonna get my next concert tickets.
Yeah, so this is installing NeuroTrader. This is all you need to do. I'm not logged in, I guess, or something. I'm not sure what that error is. But yeah, MPX NeuroTrader. Like all you need to do, go into Claude. I know I say this a lot. I sound like a broken record. And neuro and NPX NeuroTrader. In this case, I've got my NeuroTrader NeuroTrader EMVs. So NeuroTrader EMVs have all my stock trading and sports betting and all those things already running. So I can give it that, and and then say use these keys from the secrets, so, something like that, and that'll get you up and running quickly. Now it'll run here. It's not going to run forever. So if you want it to run perpetually, then you're going to need you're probably going to want to use my what could you use to do that? You could probably use this EdgeNet. This EdgeNet doesn't need to necessarily be used for sharing capacity. You could probably use it for your own capacity. But then you're gonna probably want to bootstrap it on Google, so or whatever cloud you prefer. But if you like Google, I've got a Google Cloud here. This gets you up and running with all the Google Cloud stuff. And in the Edge, I think I also have a Google Cloud example in there. Where did I put that? Edge. I gotta. Where did I put that? Here it is. Yeah. Okay. So this is how I've deployed it. So what this does is essentially allows for Google to handle your persistence. It basically point Claude at the Google Cloud CLI, and then just say deploy it. It's dirt cheap. As you can tell, I'm all about not spending any real money. So because it's idle, it uses the sparse concepts that I was telling you guys about earlier. So when it's not running, it just doesn't run, and then you have a cheap sort of neural structure somewhere. Now you're probably going to need something somewhere running all the time unless you get your hands on some of these chips. But that we're talking like $20 a month kind of cost. Cold start's pretty good. Once it's running, it's even faster. This is using Firestore database. Yeah, this is everything you need right here. It's in the EdgeNet G-Cloud folder. And then there's a browser version if you want to do that. The browser version would allow you to basically do the same thing, but you'd need enough users of your website to have it on all the time. Right. So if you have periods of time where your website isn't visited, then it's gonna break. Same general idea though. So you could create a trading site, and basically the people visiting and using the trading site are contributing the compute capacity required to run the trading site. Yeah, that's how all this stuff works. And I think we're almost out of time today. I gotta go spend some time with the fam.
Thank you.
One last, let's see where, yeah.
The Nero trading, I know you have all the packages available, but I know that you haven't, for some reason, you haven't released the GitHub repo. So I guess in the repo, then you have all wired and connected together. Is it something that you're planning to do, or you just keeping
I
it?
just, yeah, it's a bit of a mess, and there's some liabilities and around financial
Yeah,
tooling,
understood.
right? But you got to, this is really what you're running here. You see here, I ran the, this command. You got
Yes.
everything you need. Literally got everything you need. Combine this with RuVector, and you can take over the world.
But then we can add new features and stuff that we can create, and it will detect it on how it works, how you wired together.
It'll just, they all work together. All my stuff basically works. They're like Lego building blocks. Everything I build works with everything else I've built. That's why.
Yeah.
So as long as you're pointing, like if you're gonna start, you're probably gonna do something like, tell me how I can use MPX NeuralTrader with MPX RuVector. That's it. And do that in Claude Code and see what it tells you. And then follow that rabbit hole. Now, again, make sure you don't do anything that's going to put you in a position where you're going to lose money. So
Mm.
practice and understand what you're doing, how it works, verify and validate. Like, is this real? Is this actually, am I actually making money here? Those are all questions you want to keep asking. But the system will get smarter as you go, especially if you duplicate the RuVector or you use, again, in this case, you're also going to, if you're using Claude Code or whatever, tell it to use agentic flow at alpha init, and that's going to initialize the hooks for agentic flow, and then it'll get smarter the more you use it as well.
Those hooks get initialized per repo, or
Yeah. You can
Okay.
also just, yeah, so you can see them when you go to the settings .json. So I'm in the agentic flow repo. You can see that I'm using how the hooks look. So I'm using Bash for a few of them. That's because I customized it here, but basically they look like this. Oh, so this is Cloudflow actually. Let me see, where's the agentic flow? Oh, these are all Cloudflow. I guess I haven't updated the hooks here yet. Okay. Or maybe I'm combining multiple things. But basically, yeah, this is Cloudflow. One sec. Well, basically looks like this. I think flow hooks. These are your hooks, and this is your init. And you can also get different intelligence if you want to see what is happening. You could do something like intelligence. I should probably just install this, and this
so
is
it's
going to
first
show.
hooks, then init, and then the pre-train, or do we not need
Yeah,
the pre-train?
the pre-train works pretty good. The pre-train basically is learning your system and your GitHub. I do that too as part of my sort of initialization of a new project that already has existing code.
So any
Yeah, understood.
brownfield, it's all three of them.
Some combination of that, yeah. And you can point Claude at it and say, set up my hooks if you want, and do your own custom version of it. once it sees these options, generally speaking, it can figure out how to use them. Now, the init is going to give you a quick running start, like because it sets up the Claude code and settings.json. But taking a step further, there's different learning options you have here, right? So I'm not sure why it's not installing it, but if you can see here is the learning cycle completed. This is the memory consolidation, so it remembers pattern distill. It's got all the stuff.
Hey, Ruve, it looks like you added to the Agentic Flow at Alpha all of the Ruve vector automatically installs with it now. Is that correct?
Yeah, that's exactly what it is.
So that's the easiest way rather than install Ruve vector separately now.
Well, it depends on what level of tinkering you want to do, but if you're looking to build an application that's solving a customer problem, I would use this.
Yep.
This is the platform I'm going to be using that I'm actually using to do projects in various form. Now, the only other thing I would suggest, all my projects also now that I'm doing involve using the Ruve Vector Postgre. So if if you're using this, then you're really kicking it up to a whole new level.
That's
So
exactly what I'm doing.
Yep.
Yeah.
When you install when you do it that way, so it just Agentic Flow at Alpha, then the Docker for Ruve Vector Postgres, does it automatically in the default install? One of the issues I was having is that it wasn't even using it. I had to like force it to use the database to actually upload to Postgres. It just wasn't even using it by default. So that's one of the other things you just got to train it to do, or is there
No, you got to you got to use you got to give it the examples. So you've got dozens and dozens of different hooks and triggers, but none of those hooks and triggers, without a structure, you're not gonna you can't just magically work on nothing, right? So that's what these SQL files do. These SQL files give you examples of how to use it. Or once you've imported, let's say you've got an existing database and you want to import all the data, you can just tell it to use the Ruve vector capabilities, and then it'll add triggers and functions and things like that to optimize for it. But what this is doing is giving you examples on how it should look.
So if you start from scratch, greenfield, what would you say is the best? You just give it which example? It just
This one.
all these depend upon what's closest.
Yeah, I give it this one. So this one's giving you this is pretty much giving you everything. This one's got SIMD optimized. You've got different functions. You got operators. It's got everything.
So you just say create a new database based on this example.
Yeah. And this will give you everything. So you can see the different attention mechanisms. So basically what I'm doing is I'm infusing all the stuff that I was showing you in Ruve Vector directly into the spine, if you will, of Postgre. And
Yep.
once you've got that in place, saves and requests and queries and actions and logins of whatever RLS policies are now all infused with self-learning. So every time someone saves a bit of information to the database, it can spawn secondary workers. Remember the worker concept I was telling you guys about? Those workers can then work in the background and optimize it. And then once they're done, it could take 5 seconds or 5 milliseconds or 5 minutes, who knows. It'll then update corresponding learning sections and long-term memories and whatever. Or you can do like a nightly cron job, and it can go into a dream state every night at 12. And the dream state basically goes through all the information in the database that's been updated in the last day, and then archives certain bits of it, compresses others, cleans up other parts. The mincut can tell you whether or not something is stable or not, whether someone's trying to hack your system, whether something's being exploited, and all that can exist directly in your data structure. That's what these SQL files are doing. I've embedded the models directly as well, so you don't need to use any kind of secondary embedding service. So if you want to, have better some symbolic reasoning, you can use the Onyx capabilities that will embed that directly and have that again part of the requests.
And
I
you
think I'm
mentioned
gonna.
that you're using pretty a low default dimensions. You're recommending, and why is that?
Well, I use for generally speaking, I use for the Postgre, I use 384. It's faster.
34. Okay.
Eh,
Yep.
yeah, and for most things, you don't need that many dimensions. Like for the things I'm doing, everything you're seeing, I can probably get away with 128. And then just splitting it all up into multiple sort of neighborhoods within the latent space, rather than trying to pummel everything into one giant vector. I'm separating the much smaller cohesive vectors. Then I'm using these algorithms to sort of navigate and find the optimal spots within them. That works better. And remember, the computational load on vectors is exponentially more. So one dimension in 10 dimensions it isn't 10 times more. It's 1 to the 10th. So it's orders of magnitude more. So the difference between 384 and 1536, or whatever that number is millions of times more computationally heavy.
Yeah. But by default, for most apps, 384 is a good place to start.
Yeah, at least for the stuff I'm building. Yes.
So when you tell it to build a knowledge base, will it know to limit that knowledge base to the optimized amount of vectors?
Not always. Yeah, and that's the struggle we have. These systems have a tendency to want to do what they think is common. So 1536 or whatever it is, dimensions from the OpenAI embedding service.
Yeah.
I don't know why they chose that dimension, but maybe it works well for language models, I suppose. But for things that are hyper tuned and micro LoRa and optimized in real time, it doesn't work. It's slow and requires you to do an embedding service. But if you're looking at using a language model for a kind of intermediary brain or intelligence that optimizes on the fly as people save and do and interact, then 128 is going to be perfect, because then you can literally just rewrite the parameters of your language model just to be really smart at that one thing. Asking anything outside of that thing, it's stupid, but it'll know that one thing really well. It'll know everything there is to know about your heartbeat, but it won't know anything about your heart. But it can definitely describe your arrhythmia over the last 2 months.
So it seems like you're recommending building an application with lots of different potential knowledge bases to it.
Do you have multiple,
Yes.
or are you
Yeah.
using the same root vector Postgres as one combined knowledge base, or will you create multiple separate knowledge bases?
Depends how you're looking at segmentation, but for Postgre, I'm essentially using RLS policies to define access, and then vectorizing for each of the particular user privileges, a particular user, administrator, a system, and then so I'm using, but it's not as fast as the native root vector implementation because you've got the overhead of Postgre, but it's still Rust. It's still fast. It's still really fast, like faster than anyone would ever notice. I'm and a lot of the optimizations I'm doing are so fast, no one's going to notice the difference between 0.5 milliseconds versus 55 nanoseconds. Both are so fast that it takes longer for the information to write on the screen than it does for the information to be understood by the system.
That's so cool. And so once you're using root vector Postgre, is it Postgres or Postgre?
My European friends told me that I'm pronouncing it wrong, and I gotta go to the dentist. I got a chip in my tooth, which makes it hard to say. But yeah, apparently the Europeans call it Postgre.
Postgre. Okay. So when you're using Postgre, you just use it for everything. So you prevent it, like the default behaviors, it creates this JSON of your index, and that's what it then uses. It just keeps updating that JSON. Was the default behavior before I started using Postgre. But now with Postgre, you just tell it, I want to use Postgre for everything. I don't want you to create any JSON. I want you to just, I want all the new knowledge goes into Postgre, and I want you to use Postgre anytime I ask you to query the knowledge base or build something from the knowledge base.
Yes, basically. And so the knowledge, the database becomes the sort of location of the data. Now, the reason I did JSON for root vector sort of core is it gave me sort of explicit explainability of the information, so I could see it, interact with it in a way that was meaningful to me. But as I move up the stack, whether it's Postgre or AgentDB, I'm putting those into more traditional sort of ACID style structures, databases, binaries, that kind of thing.
Got it.
And
Got it. Another question that about that makes complete sense. So to really have true grounding and provability that what's coming out of the knowledge base is grounded, I've been playing with this store all of the files also in Postgre. So it stores all the embeddings, but also stores the files. So at any point in time, I can go back, because by default, it wasn't even storing the files. It was just storing the embeddings. But it's all just what you force it to do.
yeah, it depends a bit. When you say store file, you mean just a raw file or the actual binary?
Yeah, like so a bunch of the documents that I'll upload, I'll upload Excel spreadsheets, Word docs, whatever I've got, web pages, anything that I've got when I create the knowledge base. Before, I think by default it was just converting all that to embeddings. It was not keeping the original document, so I couldn't source back when I queried the knowledge base.
Oh, I
back
get
to
what
the
you're
source.
saying. You don't need this. You don't need the entire source unless like you can archive that. But what you need, what you could do with my system is a cryptographic proof and provenance. So a lot of what you're describing when you're saying proving is like if you learn something or you're giving you a result and there was multiple steps involved to get to the point of that determination, what was done to get there. What the
Yep.
system does is creates a cryptographic stamp of what was done to get to those points. So rather than sort of storing all the information that relates to it, you're storing a kind of breadcrumb traceability. And then if you want to go back and say, okay, step 33 out of 15 million there was problematic, you can then do a more in-depth review of that particular step as part of as the process that it used to get to the outcome, even if there were millions and billions of steps. Back to the HSNW algorithm, that allows you to inversely retrace your steps and provide provenance and provability that's cryptographically verified of all the steps. So that solves the black box problem of AI, right? When you make a request to a language model and you've got this kind of token output, you don't necessarily understand how it came up with that because it literally looked at every possibility in a billion parameter model and said, based on all the possibilities, this is the most probabilistic result of all those options, which is a black box. Okay, so out of a billion different things, you telling me this is the right answer, but why? How? And language models don't do a good job of explaining the why and the how. This, on the other hand, because it uses that kind of traceable, sparse, neural structure that I've been explaining, tells you exactly the path it used to get to that result and explains why the other paths have become, depreciated in the process. So you got much more
So
explainability.
by default, it takes in the metadata associated with your document. But if you wanted into Postgre, or if you're using that, by default when you upload something, correct?
Yeah,
And
exactly.
but then if you wanted to actually take a look at that, not just the metadata, and actually find the document itself, what is the best architecture of doing that? You say not storing the actual file as inside of Postgre?
You don't need the whole file. You just need to know you just need reference to the file, right?
Yep.
Where this
Okay.
is the original, and if you're at a point where you need provenance and remember this is a deterministic system. It isn't based on probabilism like an LLM is. So it's really easy to sort of have a replay of anything that's done because the replay is always the same. It's deterministic.
Yep.
There is, so replaying becomes trivial. Give me a slow motion replay of what you did to get to this point. Oh, explain each step. Optimize step 456,000 because it's a weird step. that kind of
So
thing.
if you want to get to source, have a URL addressable source that is knowledgeable.
ED25519 cryptographic stamp, which might be the same thing you're saying, just in a more
Yeah, a
crypto
deeper way.
style.
Yeah.
Yeah. Yeah, and that's going to give you cryptographic verification.
Yeah. So what do you use to what would you use to store the source where you can get those stamps?
I use hyperbolic vector space. So
Oh, no, I'm not
the
talking about the embeddings, but the source document itself.
The actual
So I want to
document.
be able to go back to the source document and say, this is where the source document came from. Let me pull up the source document.
I store
A
that
regular.
in the hyperbolic space. I store the metadata as well, where page number, whatever the value is that I need to understand the relational information. That's the benefit to a hypergraph. You can store all the various dimensions, including the secondary ones, like
You
you
could
know
reproduce the entire document. Let's say it's a regulatory document, and it's
exactly.
a
You reproduce the entire structure of the document because you're defining it in a multi-dimensional space. So you can, yeah, it exists within the structure. It was originally on page 5, but now it exists
wow.
in a different dimension. But now I can say, well, where does it exist in the original structure? Well, we've stored that it was on page 5. That's just one of the edges in the hypergraph.
But you can actually say, give me the entire document, and it will regenerate the original document.
Yes, if that's what you want. Again,
Wow.
the
Okay.
the challenge you have with traditional vectors is the Euclidean challenge. So the Euclidean challenge is the fact that the data was stored as a plane, right? A flat piece of paper. Let's use that as a visual analogy. And what putting that back together is hard because you need to do basically the algorithm itself it spends a lot of time on distortion because of the nature of a Euclidean space. So reassembling something that's been anti-distortioned is hard. It's like trying to put together a smashed mirror, right? You can do it obviously, but it's ton of fragments and it would take a long time to figure out where all the pieces go back together. I'm sure you spend enough time and effort, you'd be able to do it like a giant puzzle. This, on the other hand, doesn't have the problem of distortion because it's a hyperbolic space. I now can reassemble anything without having to sort of reverse engineer the distortion patterns.
That's amazing. It's almost incredible to get your mind around that it can take those files and compress them to such and massively compressed from its original file structure and reproduce the entire original file
Yes.
structure.
Exactly. So fooling around with it, that's the sort of things you might want to do in like a Claude Code or whatever.
Yep.
Is I've got a document, compress and optimize for hyperbolic space, and apply the graph structure along with it for navigation, and then inversely, now recreate me the document verbatim.
Yep. Yeah, I'm going to try exactly that.
And then once you have the verbatim, optimize it for speed and query performance. Now, can I do that in 100 milliseconds? Can I get that down to 10 milliseconds? Probably, depending on the size of the document. Like
Yeah.
probably a decent size, like tens of thousands of pages.
Yeah.
Now, a language model would crash and burn if you tried to do that, right? Because it's not meant to do that. You try taking 10,000 page document, stuff it into memory, and say build me the document verbatim how it existed originally. It's gonna not do that. It's gonna give you a general pretty good fidelity, maybe even 90% fidelity, but it's the 10% that'll drive you nuts.
Yeah. As far as I understand it and playing with this is like the most insane RAG system ever, most advanced. It combines the best of pretty much any commercial RAG system you can get. And, learning on top of it, I mean, it's crazy. It's so fast and easy to use. So, I mean, it's beautiful what you built, Rube.
Yeah, it is crazy. But if you're looking at self-learning data that is light, fast, and always changing, then this is the approach. And I don't know anyone else doing this, at least except for us on this call.
I'm not sure why you'd use another RAG system. That's what I'm trying to figure out. Like, why?
Me either. Like, well,
Doesn't this just kind of
the other, you use the other ones because they have distribution and people know about them.
Yeah.
Use this as soon as you know it exists.
Yeah. And the stuff people are building, like every day I get some emails or messages or whatever, and people are building the most crazy stuff with this. So which means I'm not alone in my delusion at the very least, but it appears to work very, very,
Yeah.
very well.
Stu told you that he threw a video in it and it generated out this app from the video. That's
I
like,
didn't have a chance to tell him that.
you got to tell him
Really?
that. It's
So Rube, I was up in Maine. The guy said, "Hey, here's a list of a video of where all the stuff goes in the ambulance, and we're all volunteer ambulance guys. So in the case where we've got a life and death situation, they send us back to go get the Narcan or the pediatric oxygen. Our guys don't know where to find it." I said, "Send me the video." I took the video. I had it build a knowledge base in RuVector and had that turn it into a mobile app that had voice in, voice out, speech to text, text to speech, and to put all the images from the video as to where the components were actually on the ambulance. And it was start to finish in 31 minutes.
Crazy. Yeah.
Yeah.
So you can take a step further. When you start looking at my mid-streamer capabilities, you can do that in real time with a video feed. So you can stream the video directly to the system.
That's interesting.
Yeah.
wow.
We got to
Yeah,
figure out
real
what
time.
we can do with that functionality.
Yeah, so this system doesn't. This system works back to the dynamic min cut. That means I can do all that crazy stuff on a stream of real information. So I can detect, I can invoke background workers, I can do all these things while the information is flowing. Unlike an LLM where you make a request and wait for a response, and you can fake it to make it look like it's faster by streaming the response, but the reality is it's episodic. Ask a question, get an answer, right? No matter what. And even when you look at the real-time capabilities of OpenAI and some of the other guys in the space, they're still essentially episodic. You're still in essence, trying to invoke things and wait for the response based on those invocations. There's none of that with this, right? You're looking at the sort of jitter and the noise and the information in between and making determinations based on not only what it is but what it isn't. More what it isn't than what it is. And I gotta go here, but the last comment, the weird, and this is where we started. The weird quirk of all this stuff is the sort of adversarial element. When you start realizing that the best questions are not the most direct. Tell me everything I don't know. Tell me everything that's missing. Tell me, what's wrong. How's it broken? How's it going to be exploited? That's all the sort of negative space. That's what we're really doing. We're focused on the negative space, and the entropy and complexity of the things that sit in between the things that we understand and see in these platforms. That's the part of this that's the most mind-bending of all, right? It's that tension.
Cool.
That's it. That's all I got for today, guys.
Later.
Thank you.
Happy New Year. Hopefully that was helpful.
Happy New Year.
All right. See you
Bye-bye.
soon. Okay.
Best way,
Bye, guys.
best way to start the year. Bye. Thank
Yeah.
you.
All right. No problem.